Okay, let's take a look at the adrenal gland. Now, when we look at the adrenals are also known as the suprarenal. Why? Because they are above the kidneys. When we look at the adrenal gland, we will see an outer portion called a cortex. We'll see an inner portion called the medulla. So this outer portion from here to here, that's the bark of the tree. That's called the adrenal cortex. And the inner part, the inside, is called the adrenal medulla. Now, it's important to know, what does the adrenal cortex produce and release, and what does the adrenal medulla produce and release. So let's look at the adrenal gland. We'll look at the cortex first. And histologically, the adrenal cortex is divided into the zona glomerulosa, the zona fasciculata, and the zona reticularis. So these are the three regions that we can see histologically. This is again, you look at the adrenal gland, you have the cortex on the outside, the adrenal medulla on the inside. So this outer portion, the first three layers histologically, are the zones: the zona glomerulosa, zona fasciculata, and zona reticularis. Once you're past this region, you're in the adrenal medulla. Okay, so the adrenal cortex, when we look at the glomerulosa first, that's going to produce the mineral corticoid. The mineral corticoid is called aldosterone. Aldosterone's job is in retaining and holding on to sodium, salt. Aldosterone is a mineral corticoid. What mineral is it involved with? Sodium. Okay, holds on to sodium, kicks out potassium. The zona fasciculata is going to secrete glucocorticoids. The main glucocorticoid is called cortisol. That's the biggie. Cortisol. The innermost portion is the zona reticularis, and that's going to secrete androgens, okay, like testosterone. Once we're past that, we're in the adrenal medulla, and that's going to push out epinephrine and norepinephrine, the inner part. So the zona glomerulosa secretes mineral corticoids. Remember, that's going to be aldosterone. Aldosterone. Think of sodium for that. The zona fasciculata, the glucocorticoids, we're thinking cortisol, cortisone, corticosteroids, cortisol, and the zona reticularis secretes the weak androgen hormones with more of a masculinizing effect. Now, aldosterone is that major mineral corticoid secreted by the adrenal gland, and it's going to regulate sodium and potassium balance. It's going to try and hold on to sodium and push out potassium. They move in opposite directions. So let's look at the renin, angiotensin, aldosterone system. Sometimes it's called the RAAS, renin, angiotensin, aldosterone system. Renin, angiotensin. Angio, like angiogram, angiology means blood vessels. Those means blood vessels. And when I look at tensin, I think of tension, the tension of blood vessels. Aldosterone, we know sodium involvement. And renin, the first three letters of renin, think of renal, that's kidney. So we have some sort of triggers or causes of decreased blood pressure and blood volume. So perhaps the person is dehydrated, maybe there's a sodium deficiency, or they're shot and stabbed and they're losing blood. As a result, there's a decrease in blood volume and a decrease in blood pressure. And that's not good for the kidneys to have low blood pressure. There's always got to be fluids going through the kidneys. So there's some sort of decrease in pressure. Now, your kidneys are going to release renin. Your liver is going to release angiotensinogen. Now, ogen means it's inactive. So this angiotensin, this chemical that's involved in regulating blood pressure, is inactive. But when renin bumps into it, it knocks off the ogen, and angiotensinogen now becomes angiotensin 1. And if there's an angiotensin 2, it is safe to assume that there will be, if there's an angiotensin 1, it's safe to assume that there will be an angiotensin 2. What converts angiotensin 1 into angiotensin 2 is something that the lungs make, called angiotensin converting enzyme, known as ACE. ACE is angiotensin converting enzyme, ACE, angiotensin converting enzyme. It is zinc dependent. The lungs and zinc go hand in hand. We know that with COVID, right? Zinc deficiencies in people were really, really bad. People that had the least amount of complications had high enough zinc levels in their system. So let's review. Kidneys make renin. Renin takes the angiotensinogen that the liver produced, converted it into angiotensin 1, and angiotensin 1 is converted into angiotensin 2 by the lungs angiotensin converting enzyme. ACE made that conversion. Now we have angiotensin 2. What is angiotensin 2 going to do? What's its job? Angiotensin 2's job is to increase your blood pressure, and it's going to do so in a variety of ways. It is involved in constricting the blood vessels. So you got vasoconstriction, vessel constriction. That's going to increase blood pressure. It's involved in ADH and aldosterone production. It's going to be involved in salt cravings, and it's going to make you thirsty. So you got constricting blood vessels. You are craving something salty, salt cravings. So you eat potato chips and pretzels. And what happens after you eat potato chips and pretzels? You then get thirsty. So you drink water. The water that you drink is now conserved because antidiuretic hormone, antidiuretic, you're going to hold on to the water you drank. And look what aldosterone does. Aldosterone is going to hold on to the salt or the sodium from the salty pretzels that you ate. So you got salt intake, water intake, hold on to the water that you drank, hold on to the salt that you just consumed, plus constricting of the blood vessels. All of those things have compound interest to increase your blood pressure. Okay, and that's what we see going on here. You got to have increased aldosterone, you're going to have the adrenal cortex, cortisol increases blood pressure. We're going to have water reabsorption due to antidiuretic hormone. All of these things increase blood volume and return the blood pressure back to normal. That's the RAAS system. Now, still with the adrenal gland, remember, There's an adrenal cortex, and then there's the adrenal medulla. And both cortex and medulla are involved in regulating stress. It's just we have long-term and short-term stress. So short-term stress, you have the brain that sends a signal right down the spinal cord into the sympathetics, right to the adrenal medulla, and that's going to increase your heart rate and increase your blood pressure. The liver is going to convert glycogen into glucose. It's going to dilate your bronchioles, increase your metabolic rate, increase your cholesterol, increase your sugar, increase your heart rate, increase your energy so you can survive if a tiger is chasing you. The adrenal medulla is going to push out adrenaline and noradrenaline. These are called catecholamines, epinephrine and norepinephrine. Now, short term, this is good. This is like survival. The adrenal medulla helps us in crisis situations, but if we have more of long-term stress, this is when the adrenal cortex is pushing out glucocorticoids and mineral corticoids. Remember, the mineral corticoid is aldosterone, so that's going to increase your blood pressure, and the glucocorticoids are going to increase your blood glucose levels, and cortisol also suppresses your immune system. So you have high blood sugar, weakened immune system, you have high blood pressure, high blood sugar, weakened immune system, high cholesterol. And when this is for a long period of time, stress can increase your blood pressure, stress can increase your blood sugar, stress can weaken your immune system. Is it no wonder stress can kill? Not so much the short term, but the chronic long term stimulation of the adrenal cortex leads to something known as adrenal exhaustion.